This is where we left off yesterday. We had just talked about how to calculate the shape, mean, and standard deviation for each population individually. So now I want you guys to tell me, when we describe the sampling distribution of the differences between the proportions of orange M&Ms and Skittles. So we're going to do X minus Y. What would my shape be? Still approximately normal. When we want to check the shape for a difference of proportions, you have to check large counts for both samples. You have to check large counts for both samples. How would we find the mean for the difference? Yes, mean of X minus mean of Y. So we're going to do 0.25 minus 0.20. We get 0.05. True proportion from population 1 minus true proportion from population 2. How would we find the standard deviation for the difference of the two populations, or the two sample proportions, rather?
The square root of the standard deviation of M&M squared plus the standard deviation of Skittles squared.
There we go. We're going to do the square root of the standard deviation for M&Ms squared plus, remember we never minus with standard deviations, plus the standard deviation for Skittles squared. We end up getting 0.0834. I lost my square root symbol here. This needs a square root over it all. There we go. Ms. Bolt and Mrs. Bolliton calculated a difference between proportions of a positive 0.08 from their samples. Calculate the probability of getting this difference in proportions or higher purely by chance. What kind of a distribution is it? Approximately normal. We know the mean, and we now know the standard deviation. So what do you need to start this problem by doing? Draw a picture. It's approximately normal, so draw your normal curve. What goes right down the center? The mean. Then you need your boundary line, and you need to get your shading either to the left or the right, depending on whether it's a greater than or a less than. Make sure you have the big capital N for normal. And then what function do you actually have to use to calculate this? Normal CDF. So your picture should look kind of like this. Bye. Good luck. Thank you. You as well. When we go to do a normal CDF, we need to write probability notation. My probability notation starts with what capital letter? P. Big capital letter P for probability, and then parentheses. And then it would be the probability that P hat 1 minus P hat 2 is greater than or equal to 0.08. We said we're going to use a normal CDF for this. What would my lower boundary be? 0.08, because that is the farthest to the left that we have shaded. Upper boundary? Infinity, something stupid big. Since we're talking about proportions, what is, yes, the smallest enormously big number that we could use would be a 1 here, because we can never go over 100%. But I usually go with something absolutely ridiculously large. And then we want the mean and standard deviation. Please, please, please make sure you are labeling these pieces, lower bound, upper bound, mean, and standard deviation. And then, what do you get? What is this probability? Yes. 0.3595. 0.3595. And again, this should be p hat 1 and p hat 2. I don't know how I lost my hats on there. All right. We are almost done. Do you guys have any questions before we go and look at the check your understanding? Yes.
Why don't we do 1 minus, please?
So when we do normal CDF, I don't have to do the 1 minus because normal CDF can do either tail.
Oh, so it's binomial.
Yes, binomial and geometric CDF, we have to do a 1 minus if it's a greater than. Yep. Why? Just these calculators have not been programmed to do a greater than for binomial or geometric. It just, that's the simplest explanation. Different programs can do that, and then you don't have to worry about the 1 minus. Yes. I don't. All right, let's flip this to page 15 and finish us out. Quick notes. Quick notes. When we do a sampling distribution for p hat 1 minus p hat 2, we need to check our shape. It will be approximately normal if my large counts for population 1 is greater than or equal to 10. So we have to check to make sure that population 1 is approximately normal. And we have to check large counts for population 2. We have to make sure that population 2 is also approximately normal. If they're not, then we can't use a normal CDF to calculate. If they're not approximately normal, then we can't use normal CDF to calculate probabilities. So differences in sample proportions means extra work. It's kind of like 2 problems in one because we have to check large counts for both. Our mean is whatever the true mean of population 1 minus true mean of population 2 is. Variability. We have the variance for population 1 plus the variance for population 2 underneath the square root. And now this piece right here, they will rarely, if ever, prompt you for this, but you are expected to remember, if you ever go to calculate standard deviation, you have to check 10%. They will not prompt you on that. You have to check it anyway. You have to check 10% for both populations. If we don't pass the 10% condition for both populations, then we cannot calculate the variability. We cannot calculate standard deviation. Has to pass for both. I only briefly want to mention over here with normal probabilities, we haven't talked about z-scores very much recently. If you guys remember, a z-score is how many standard deviations we are away from the mean. I'm bringing this up and talking about it because a lot of times you'll see z-score stuff show up as multiple choice answers. When we calculate a probability, we just use normal CDF on the calculator. But we could also calculate a z-score and use table A. To calculate a z-score, we need the statistic minus the parameter divided by, what is this thing? Standard deviation, yes. If we want to calculate a z-score, we do the statistic So information gathered from our sample minus the parameter, information gathered from our population, divided by the standard deviation. All right, just to check your understanding, and then we are done. You guys ready? All right, let's check this out. At Westville High School, there are 315 seniors and 389 juniors. 65% of the seniors have parking passes, and 42% of the juniors have parking passes. The statistics teacher selects a simple random sample of 30 seniors and a separate simple random sample of 30 juniors. Let p hat s minus p hat j be the difference in the sample proportions of seniors and juniors that have parking passes. I want you guys just to answer question number 1 right now and show any work that you would need to show to justify your answer. What is the shape of the sampling distribution of p hat s minus p hat j, and why? I'm going to give you about a minute and a half to answer question number 1, and then we'll check your answer with mine. What is the approximate shape? Approximately normal. What do you have to do to justify saying that it is approximately normal? Large counts. So for your seniors, you do the sample size of seniors, which is 30, times the true proportion, 0.65, we get 19.5, that's greater than or equal to 10. And then we do the sample size of seniors times 1 minus the true probability for seniors, so 30 times 0.35, we get 10.5. As long as it is 10 or bigger, we are good. And then with the juniors, number of juniors times the proportion of juniors, so 30 times 0.42, we get 12.6. And 30 times 0.58, we get 17.4. That meets our condition, so we can say approximately normal. That unlocks what ability? Normal CDF. Now we can calculate a probability for this difference using normal CDF. All right. Number 2, I want you to calculate the mean and standard deviation. Check any conditions that you would need to check in order to be able to calculate either of those. Take about a minute and a half. What'd you say? Yes, it would be, because we don't want to choose the same person twice for our sample of size 30. Yep. All right. What is the mean? About how much? 6.96? 0.23.
What?
0.23. Remember, the mean for p hat is p. We don't do n times p. It's not binomial. This is approximately normal.
I am so dumb.
You are not dumb.
No, you're not.
You're not dumb. You just forgot, and you're just learning it. All right. What about standard deviation? What do I need to do before I actually calculate it? Check the 10% condition. For what?
If the sample size is less than or equal to 10%.
Yes, both of you guys. Sample size less than or equal to 10% for both samples. For both samples. So we have 30 is less than or equal to 10% of 315. Yep, barely, but yep. And 30 is less than or equal to 10% of 389. So then we plug into our formula. So square root of 0.65 times 0.35 over 30 plus 0.42 times 0.58 over 30. All of that underneath the square root. And you should get 0.1253. I'm going to give you guys 2 minutes now that we know that we have the correct standard deviation and the correct mean and we know our shape. I'm going to let you do number 3. We said it was approximately normal, so what do you have to remember to do on number 3? Draw the picture. Draw the distribution first, and then calculate the probability. Make sure you also have a correct probability statement. Make sure you have a correct probability statement. All right, so picture should look like this. Point 23 should be right down the center. Point 30 should be your boundary. You should have it shaded to the right because it says greater than 30%. Make sure you have the N with the mean and the standard deviation labeled. Probability statement should look like this, only it should have hats. P hat S minus P hat J greater than 0.30. Lower bound would be 0.30, upper bound is something stupid big, and then mean and standard deviation. Please make sure that you are labeling those things. And what do we get?
0.2897.
I got, yep. About 0.29 roughly. If I'm rounding it to two places, it's about 0.29. Yep, 0.2877 would be fine. All right. Do you guys have any questions? Any questions? Homework is due the Monday we get back, and I just want to impress upon you, I know nobody wants to do work over break. I'm sorry that we don't have class time. They cut into my class time. One thing I want to impress upon you is how important this homework is. Second semester, the first chapter we do second semester is about sample proportions. Like we have a whole chapter over sample proportions. The second chapter is all about differences in sample proportions. So what we just spent the last 3 days doing when we did the Reese's and the M&Ms and the Skittles, that's the first 2 chapters, second semester. So making sure you're practicing now, asking questions, clearing up any misunderstandings, you will make your second semester so much better if you work on this. All right. And they are going to dismiss us in less than 3 minutes. I really want to pass your tests back. Gonna have to wait until after break. I promise I will get to this. I am so sorry, guys. Okay.